We are live with another edition of our live stream. This is the first one already. As usual, our great CEO, our visionary CEO, as I always call him, he thinks it's too cheesy. I think it's the truth. Shashank, please say hello to the community and can you update us with the latest updates?
Yeah, sure. So I'm a bit jet lagged. So traveling to SF, it takes a long time, and that's why we haven't had the session the last week. But this week we have Sreeram. He'll be joining in a few minutes. Until then, I thought it's best to give you some community updates. So last time I checked, there have been more than 5 million sessions on the platform, and that's a lot. It's way more than the whole of Ethereum chain can handle. So we are working on making it more scalable. In the future, we might also launch on some L2s since they're more scalable. But yeah, so we'll have a new patch soon. And that patch is more about matchmaking. Since a lot of you guys have mentioned it's taking a lot of time for matchmaking. It's supposed to, because there's just too many sessions at a time. So we'll ensure that happens quickly. And secondly, another update to ensure there's fewer bots on the platform. Now we'll look at your balance on Ethereum mainnet to judge if you are a bot or not. And if you have a certain amount of Ethereum on the mainnet, then you'll be given priority in matchmaking. So with these two updates, your experience should improve a lot, and you'll be able to participate in more sessions. And we'll be able to reserve our bandwidth like to the actual users and not the people who are running the bots. So yeah, that update should be out soon. Other than that, you guys already know this new space we are launching with Dobby. So this should be a welcome change from the only space we have right now, the wrap one. So yeah, good to have something different. There'll be more spaces in the future, but yeah, let's just start with Dobby and see how it works. Even I haven't created agents on it and tried it out, so I don't know how it will turn out. But yeah, really looking forward to the kind of agents you guys will build and how they will perform against each other. um, yeah, so eagerly looking forward to it. So yeah, lot of updates coming soon. Lot of important partnerships will be announced in the future as well. We really love the support that you guys have shown us so far, and the kind of problems we are having are the good ones, where we have to work day and night to ensure our platform can handle the kind of traffic we are seeing on the platform. So yeah, thanks a lot for giving us those good kind of problems. um yeah, so the team is working on it.
And
And
it's like three of the four things most requested you just answered. Everyone wants to know about matchmaking,
uh-huh.
about Dobby, and about if there is bots and Sybil. And the fourth one is, of course, re, um, removing an account and tying another one because some people like connect the wrong account. They want to
Uh-huh.
disconnect it. Do we have an update on that too?
Yeah, so the another one is where you will be able to disconnect from your previous account and connect with the newer one. So if you accidentally connected something, then you can just change it. And this, I think there's a misunderstanding on this. So you only need to connect one of the accounts, either Discord or Telegram. You don't need to connect all of them. So yeah, just connect one, and you should be good to go. But yeah,
Absolutely.
the major update is about preventing bots. So everyone can get more number of sessions to play with. You can iterate more on the kind of agents you guys are creating. So yeah, we should. It'll be a good experience for everyone.
And did you see, guys, like your wherever you have like suggestions, like giving us the good problems, we address them fast. And today you can expect some, like patch updates. And also, I want to take this to thank you, like face to face, everyone in the community for coming together yesterday, like showing support to the campaign. We made a lot of noise together. We're gonna put, Fractional in the map, and really thank you for the community.
Yeah, so it had only been a few hours since I landed in SF, and I was just looking at Twitter, and I saw Fraction AI trending, and that was like, oh, cool, we are doing pretty well. So yeah, it's always nice to see those moments, and great to see people really talking about us. And yeah, but I think that one space will be a huge success. Even right now, the team is working with their APIs to ensure that it can handle the number of users we are having. Because believe me, the number of sessions that are on our platform every minute, it's difficult for any API to handle. It just needs so many GPUs to handle so many requests. So we are working to ensure we can give access to as many users as possible. It's just too many users right now.
Yeah, true. I have a question about Dobby. This is funny one. People ask it all the time. Maybe you know, maybe you don't. So they
Mhm.
ask me what's behind the name of Dobby. Is it the character of what's called Harry Potter? Is it based on
So yeah, I've had this discussion once with Himanshu. Don't quite remember the details, but I think it came from there. The Harry Potter character, which was like really helpful, really aligned with what he wanted to do, and just did that. So I think it connects really well with the things sentient are going with, community
that?
aligned. And I don't think there was a better character who was more aligned with Harry Potter. He literally gave his life for him. So I think it ties in somewhere into that. But yeah, I'll probably need to asking more about it. That-
And
that's my understanding.
you know what's funny? People are already making basically like date nights between Dobby and Arya because they have like a dog as a platform.
Yeah, yeah, yeah. So the only thing is the design of Dobby. It's more cartoonish, and of Arya, it's more of a 3D model, a rendered 3D design similar to Disney Pixar movies. So it just doesn't gel together all the time. We'll probably need to make some changes to ensure they seem to come, which make them look like they come from the same space of design. So yeah, I think some of our community members can work on that, where they can probably make Dobby more 3D like, or make Arya more cartoon like, and then they'll feel more aligned, if you want to call it that.
Yeah, let's make it happen. I
Yeah.
have a question about fraction AI. That like this morning we saw many people like writing about us and everything. So there was this great article. So they were saying, and I want perhaps you have some thoughts about that. They're saying that most AI models like they're plateauing because there is no more data. So
Mhm.
like they scraped all the data and there is no more. And the article says, but there is a solution. Fraction AI, they have these thousands of I guess that's the number they had, like when they wrote the article of agents,
Mhm.
like competing with each other and creating like synthetic data. What do you think
Mhm.
about, like, yeah, these things?
Well, they are right.
Yeah, I know.
It's
Let's
general
rate it.
consensus. Yeah, so it's general consensus that the models right now have kind of seen all the data that is there on the internet. So the models right now know what the language looks like. They can write perfectly good sentences, better than most people can. So these models, if they get some data from some amateur novelists, it won't be that useful for them, because they can already write in that kind of language, generate that kind of data. So what it needs is really specialized data, really high quality data. And the best way to generate it is through those models themselves. So just make them compete, ensure people are incentivized to create agents that generate that level of data. And then you can just make them compete against each other, so the incentives are aligned. And finally, the kind of highly distilled quality data that you get, that actually improves the model performance. And it's not something that hasn't been tried. So for example, if you read DeepSeek paper, the B3
Mhm.
one, they kind of use something similar in their approach called GRPO. Don't want to get too technical, but yeah, it was something similar, where they generate multiple responses through their model, and then they have a function to judge which one of them is good. So what we are doing at Traction AI is just a decentralized reinforcement learning platform, where we allow anyone from anywhere to create agent, compete, create data, create the better models, and also incentivize to create better agents that create better data. um, yeah, that's like uh, it's building for the future, because right now, even till now, everyone has been focused on just getting the data that is already there on the internet. But yeah, I think we are way past that
Yeah.
point. Even all the big labs, they kind of generate their own data, and all their effort goes into filtering to ensure data quality. And that's what we are doing in a decentralized manner. So yeah, we always build for the future.
It's true. You are as good as the quality of the data that you have, and funny, like majority of Web3 projects, not majority. I'm sorry, I apologize. Take that back. A lot are Dino, decentralized in name only. But
Mhm.
Fraction AI is like 100% decentralized. People, even like when we had Metaverse Machine, like people from all over the world come in, help training the AI, completing battles. It doesn't matter where you are, doesn't matter your political, leaning, like you're from the right, from the left, and this is like actually something that is necessary. A lot of people talk about doing that, but very few people like actually do. So like it's great like that we're like totally decentralized in that.
Yeah, and it might not be very clear right now where the decentralization comes from. But as soon as we launch our white paper and we show how the FRAC token is useful, it'll be more clear. So the FRAC
Hmm.
token is more about judgment,
Accessibility. Hmm.
in ensuring that your model outputs are, or your agent outputs are being judged by a network of decentralized judges, which are not controlled by one single authority. So that's where the use case of frac token comes in, and you guys will have more information once we launch that white paper. So usually what happens with web3 platforms is you launch a white paper, and then you launch a token, and then you say, oh, we'll build this, we'll build that. What we wanted to do was launch a platform first. People should have something to play around with, and once they like it, then we can show them what the technicalities behind it. But the number one step is people should love the platform that they're using.
And I think this is why like everybody loves you, and this is why like we have the community, like everybody like gets motivated, everybody builds. It's because talking the walk, walking some people just, oh, it's good. Guys, this is my
Yeah,
first live
I
stream.
mean, so I'm not like against that. That's like an approach you chose to take. So
Yeah,
feel free to do whatever you want. I just prefer users to have something to play around with.
yeah.
And just a white paper is not something anyone can play around with. So it's I just find it good that I can just send someone a link. They can go to the platform, try it out, and understand what it is, instead of me telling them what it is.
So our
And
guest is here. I'm
oh,
sorry for
nice.
interrupting. So I'm gonna introduce our guest. Sure, I'm gonna introduce him, and then I'm gonna disappear, leave these geniuses talk between each other, and then teach us like, and we learn. We're gonna have so much alpha and everything. So without further ado, hey Shuram,
Hey,
thank you
hey,
for.
hey, hi, Shashank.
Hey, Shriram. Always nice to see you.
Amazing, amazing. Really excited for this. Sorry for the delay.
Yeah. So, where are you right now?
I'm in Seattle.
Oh, nice,
I'm
nice.
at the office. We have a rugged look office,
Yeah, I can see that. Will you be there at Eat Denver?
likely. Yeah.
Oh, okay.
I mean,
Yeah.
sure, for sure. Actually,
Yeah. Yeah. So, I think most of our viewers already know you, but it'll be just great to.
yeah, of course. I'm super, super excited to be here on this Fraction podcast. I'm Sreeram. I started Eigen Labs 3.5 years back. Used to be a professor at the University of Washington, Seattle. Um, Started the UW blockchain research lab where I used to work on consensus scaling since 2018. I've also done a bunch of work on AI, genomics, other stuff before I got into this.
Mhm.
In fact, one of my, I was lucky to work with David Baker, who got the Nobel Prize in chemistry last year
Oh, nice.
for using AI to predict protein folding.
Mhm.
So yeah, so I've done a lot of other things before, but been very, very interested in blockchain, crypto over the
Mhm.
last 7 8 years. So really excited to do this, and really excited to see like this crypto AI becoming a real thing,
Mhm.
which
Mhm.
yeah, which is an obvious fit, and happy to talk more about it.
Yeah, nice. So I do understand restaking is pretty broad, and what Eigenlayer does, it's way bigger than, or like covers a lot of areas than just AI, But happy to understand how you guys are looking at AI and what Eigenlayer is doing to ensure.
Yeah,
Com-
yeah. So the way we think about eigenlayer is eigen in German for your own layer. So anybody
Mhm,
should be able to come and build whatever things that they want.
mhm,
And so that's our driving principle. So we call it open innovation, right? The idea
mhm.
that we can come and innovate.
So
And
I thought it came from eigenvectors and eigenvalues.
sort of, but eigen in German just means your own, or yeah. So we just dual use it.
Okay.
Uh, So the math geeks, we talk about eigensystems, eigenvector, eigenfunction,
Mhm,
but the the more common usage is just like uh, so when you think about like eigenlayer, in fact, like we had the name for the project eigenlayer and like our output goal of like open innovation before we knew even what restaking is.
mhm,
So we're not a restaking project. We are a project that is trying to figure out what is the set of like technologies needed to maximize open innovation. And
mhm,
one thing we started with is, oh, actually, whenever you want to build a new network, one way to think about it is eigenlayer is providing trust for off-chain computation. You want to do some off-chain computation, you want to underwrite trust for it.
mhm,
Who do I trust it? And so eigenlayer is a mechanism for underwriting trust to off-chain computation.
mhm,
And how do you do it? Oh, one way is, oh, Ethereum stakers have already staked and they have a lot of money at risk. They can
mhm,
promise to run other services with the risk and credible threat of slashing that they can
mhm,
actually get their money. So that's one starting point of like the eigenlayer ecosystem.
mhm,
And so if you look at our market structure, we have stakers, so people who stake, operators provide node and
mhm,
computational infrastructure, then AVS developers. We call these, so we used to call AVS actively validated services, which
mhm,
means there's a set of services that actually need like to run validators, right?
mhm, mhm,
We now have rebranded it to autonomous verifiable services. Autonomous, they run on their own. Why do they run on their own? Anybody can come and stake and keep the service running.
mhm,
Verifiable, if they do something wrong, they're held to kind of like slashing and on-chain verification
mhm,
services, right? So services that run on their own and are held to accountability. So autonomous verifiable services. That's our ecosystem. And if you look at, another way I just phrased it is eigenlayer is just trust for off-chain computation.
uh-huh.
And what is the category of computation that everybody is excited about and wants to do? Is AI.
Yeah.
So that's the fit, right? So the first level of fit is pretty obvious. It's
Mhm,
kind of like the same reason. In fact, one way we think of ourselves is we are the verifiable cloud, right? So
mhm,
it's cloud, but it's verifiable, right? So
mhm,
that's doing the right thing. And so the same reason why, for example, at Microsoft, Satya Nadella recently said they're spending $80 billion this year on AI in
mhm.
Azure, right?
Yep.
And so they're a cloud and they're spending $80 billion on AI
Mhm,
because this is going to be the most important use case in the cloud. So
mhm,
if we are the verifiable cloud, like what is the most important use case in the verifiable cloud? Is AI. So it's kind of like
mhm.
obvious that that's the fit.
Okay.
So that is, I think, like at least phrases why we are interested in AI and what is our angle is we want to just supply trust to
Mhm.
all kinds of AI services. And then we can go deeper into like agents, autonomy, all this stuff, which I'm very
Mhm.
excited.
Yeah, yeah, sure. So when you say verifiable cloud, what is it that's getting verified?
Yes, any service. Okay, great question, right? So when you're saying that I'm running a service, right?
Mhm,
So let's take an example of um, I'm running an AI inference, and I
mhm,
want what is a verifiable service or a verifiable AI inference is
mhm,
I promise that I'm running this AI inference, and what is getting verified is that you actually ran that particular model and produced that particular output. That
mhm.
would be the specific thing that you want to be verifiable, right?
Yep.
So what is verifiable is contextual, right? Each application or service needs something to be verifiable, and that's what we make verifiable. But in the case of AI, like something like inference or training, do you want to do verifiable inference? You want to do verifiable training? You want to do verifiable data? I know I want to do a data market where I'm selling the data, and then like whenever that data is getting used, I want to get paid for it, right? So that could be an example. It could be verifiable model benchmarking. I want to benchmark a model and know like how good it is doing on like this suite of data, but who are you trusting for that? Is this like network where people are staked, and if they do something wrong, they're going to lose their stake? So these are the examples of what verifiability in AI would look like. But in general, we use this term verifiable cloud because I think this is the kind of like fundamental value proposition of blockchains itself. It's verifiable, right? That the system says, when Ethereum says that something has happened, it happens because you can self-verify it, you can re-execute it. And if the people who said it didn't do the right thing, they're going to lose that stake. So the same set of checks and balances that make Ethereum secure is what makes like EigenLayer the verifiable cloud.
Oh, nice. Actually, let's go through an example to understand the difference. So if I'm hosting my model on some cloud provider for inference, the model is running on their cloud, and they give me an API, I call their API, I get a response. How would that process differ in case of a verifiable cloud or a verifiable AI inference?
Okay, so awesome. So this is basically speaking to how does an AVS work? So like I said, AVS is full form autonomous verifiable service. But what is actually happening? What is happening is the service says, oh, if somebody stakes more than $100 million worth of ETH or Eigen, whatever other thing, then they can actually run this service. So that's the service condition. So service provision says you need economic security. Now, anybody who has ETH or USD or whatever tokens that are acceptable, come and stake that and then say, I'm running that service. So unlike hosting that service on the cloud, where that cloud goes down, then your service is dead. This service is kind of virtualized in this way that anybody who stakes 100 million can actually come run that service. So that makes it autonomous. So what that service is a particular code base and saying, hey, whenever somebody makes a call, this code base, you have to stake this much money and then run that code base and then produce the result, aggregate the signature from all those people who are staked on chain. On EigenLayer, we maintain the state of who has staked how much, what is their signature IDs, and so on. Then when you when that service submits a result, it means anybody who has staked that much money submits a aggregated signature, right? So we have the BLS signature aggregation. We aggregate the signature and then prove it on chain that, oh, people who have staked more than 100 million have promised that they've run this and then they got this answer. So the API for this service is, think of like you can have on-chain service or the service is providing results to a smart contract on-chain or to a user off-chain, one of these. But let's think of on-chain. Then what happens is, somebody can trigger a command and say like, run this AI inference. Then these nodes who have staked run the inference and then get the result and then put that result on-chain. And once that result has enough economic security behind it, that result is considered valid. So that is the kind of core service model of like EigenLayer. So that's why we call it the service. The services are now autonomous. Don't trust any one person or anybody to run it. And verifiable. In this case, they have this measurable amount of economic stake or security. And there is a protocol later to re-execute, verify that, like, if somebody challenges that this people who put $100 million were malicious, then there's a slashing adjudication process that basically like results in them getting slashed. So that is the kind of like net structure of the system.
Okay. So if I understand it correctly, in this case, verifiability comes from the fact that if someone is running that model inference, they have to stake a substantial amount of some tokens to ensure they're running that, and they risk losing a part of those tokens if their service is not good.
That's correct.
Okay. So in case of like an inference, LLMs are non-deterministic.
Yeah.
How do you evaluate if
Okay, this is the most fun problem that in AI. So inference is indeed non-deterministic, and so you have like a whole bunch of issues when you try to do. So the basic thing, the basic property that we need is some level of, if you try to re-execute the service,
Mhm.
then you should get the same answer, or at least the same answer with
Yeah.
some probability.
Uh-huh.
Otherwise, you can't even verify that the service was run correctly or not. Okay, so how do we solve this problem? So for the first set of things, what you need to do is, when you're doing the AI inference, you
Mhm.
can box it pretty tightly. And box it means what? You control the random seed, you control the temperature, you control initialization. Everything is tightly controlled, and you can get like a large degree of determinism just with that, right?
Mhm.
If you control seed temperature, all this stuff. So that's number one. Number two, what we found is, even if you did all this and you run on, and there is still some kind of hardware abstraction that matters. For example,
Mhm.
GPUs do asynchronous, multiplication, and
Yeah.
results get aggregated. There's some floating point like
Mhm.
things which are not exactly identical across GPUs and so on. So all those stuff still lead to some amount of non-determinism.
Mhm.
But what you find is, in a lot of those cases, if you re-execute it with the same on the same device, you can actually like get determinism.
Mhm.
But there is like higher grades of determinism, where what you do is, if you're doing floating point computation with like 16 digits of precision,
Mhm.
you always round it down to like 12 digits of precision, so that
Mhm.
any inaccuracies don't get compounded, and every round you're still getting 12 digits at deterministic precision. So
Mhm.
this is a much more intricate kind of like, okay, so to actually get deterministic inference, you have to go inside how the model is actually running. So you
Mhm.
have to go to the like CUDA or whatever, like model compiler that you're using, and then like to meddle with it a little bit to actually
Mhm.
get this kind of property. But we have teams which are building things like this,
Mhm.
and that's so when you get so using this, what you can get is high grade determinism.
Mhm.
So you get varying grades of determinism. Just fix the seed, like, and temperature, that'll give you some level.
Mhm.
Then you go to like, oh, fix the seed and temperature, and you run it on the same device, then you get some more determinism. And then you do like this more fancy stuff, then you can get like military grade determinism. So you can, and eigenlayer permits you to use various kinds of slashing models to like say, oh, it's socially decided, it's actually like decided algorithmically, and so on. Like, you can move through this gradation gracefully in eigenlayer.
Mhm. Mhm. Yeah, so I've actually thought about this problem a bit, uh, and I believe the best possible solution would have been if you ran inference and you could show the activations that were computed during the inference. But the thing is, network has like billions of parameters, and that would take up a lot of size. So how about something like this? When you call for inference, say there are n network activations possible, so you give choose five random numbers like activation number 1, 10, 30, 70, and 1,000. And whenever the inference happens, the provider has to give you activations corresponding to those to those weights. And then later, if you want to contest against it, then you can just run it and verify if those activations were correct or not.
Yeah. So these are mechanisms. I just chalk them all up into like, how do you do fraud proofs, right? So
Uh-huh.
that's what you're talking about. Like, what level of commitments do you make? Do you commit every neuron, and then like you can then like just re-execute one neuron, like you don't need to re-execute everything, or you commit like some intermediate layers, or you just like re-execute the entire inference.
Mhm.
So you can do any of these things. It's just a matter of like the cost versus the data that you're writing in the normal mode, right?
Uh-huh.
The cost to do reinference. Uh, but if you think about like stateless inference, just the cost to do one inference cycle. So a lot of our thinking, in at least in Ethereum, has all been bounded by what you can re-execute on EVM.
Mhm.
which is, I think, like a very bad situation right now.
Mhm.
Because it's just a tiny computer. I feel like we're working with like a 1985 computer called
Even before.
even before. So now like you're just choking it down like into its throat, like all
Mhm.
this computation.
Mhm.
And the um the and that's what is constraining like the design choices. Instead, if you had a primitive to do, hey, if I have a challenge, if I can pay the nodes enough to just re-execute that one inference, right?
Mhm.
That's not like actually that expensive to do, right? Like it's just that Ethereum doesn't have those interfaces. Some of the new features that are coming up on Eigenlayer, you can actually just commit to some box, that some container that you're executing, and
Mhm.
as long as you can fetch the state for that container and then execute it and then see what the next step is,
Mhm.
and what the output is, you can actually create challenges, fraud proofs against those kinds of things.
Mhm.
So yeah, so you can do more complex things to reduce the cost of re-execution, or if you're trying to overfit it into like a tiny box like Ethereum.
Mhm.
But you can also just like do other things. So that is that is a complex design space there. So I'm not minimizing it, but just specifying what the trade-off is. The trade-off is the data created in the normal mode versus the cost to do re-execution.
Mhm.
And it's not that expensive to just do like, oh, just re-execute one output from an LLM, right?
Mhm.
It just takes some time and some cost to do it. And if
Mhm.
you just have a system that can actually perform it, then you don't need to work very hard on this fraud proof mechanism.
And the good part is you don't have to generate it every time, right? You only have
That's
to
right.
commit.
It's only on challenge, exactly.
Yeah.
So you can just set the challenge cost high enough that
Yep.
people are not going to waste their time like
Yep. Yep.
yeah.
So also this there can be two kinds of errors. The one is where you ran the model correctly, but the answer was still not correct. The other one is you didn't run the model correctly by itself.
That's
So
right. I think like the first one. So what the model trust model of Eigenlayer is, you took this code and ran it with this input and then got this answer.
Mhm.
Whether this code is a garbage code, like or like it's not having certain properties,
Mhm.
I think it is a very important problem, but unsolved problem even on Ethereum. Forget AI, right?
Mhm.
You have a smart contract, you think it's Uniswap and it's doing like swaps.
Mhm.
But it turns out there is some underflow, reentrancy, I don't know, God knows what bug.
Mhm.
Then you lose your money, right? Like that is the Ethereum trust model, is
Yep.
that what you're getting guarantees on is this code is what is running,
Mhm.
not that this code is doing what it says it is doing.
Mhm. Mhm.
That was whole other level of trust, or like modeling. So totally concede that point, and this is kind of like out of bounds for what Eigenlayer provides, but it is in bounds for a lot of research that other people are doing. Like
Mhm.
I would say this falls into something like alignment, right?
Mhm.
Like how do you know that the model does what it says it does, right?
Mhm.
Is the model aligned to certain values, or is the model aligned to like certain principles?
Mhm.
So there is a bunch of like, and how strongly protected is it against things like jailbreaking and backdoors and data poisoning and all this stuff.
Mhm.
So
Mhm.
there's a bunch of interesting stuff there, which is pure AI land research. And then like, so you can decompose the thing into like AI land research, like, oh, figure out whether this model has certain properties,
Mhm.
and then separately figure out that this model is what is being executed. And like
Mhm.
what we obsess about is this model is being executed, and then let the AI people worry about like, is this model have this properties?
Yeah, I think it's just good to understand that verifiability is not given a query. I am verifying that the output is correct. Verifiability is given a query and a model M. I am giving you a guarantee.
Assurance that like that model ran and this I give this answer.
Yeah,
Exactly.
this
That's
is
absolutely correct.
this is the output. Yeah, that's pretty
Yeah.
nice. Also, how do you think it works on the training side, the verifiability? Do you look at the network updates or
Okay, great. So I think before we dive into the taxonomy of which level of verifiability is good enough. Like one thing to think about is, firstly, what is the use case that we're talking about, right? And you can just think of model inference, but also you can think of agents. So let's start with agents, right? And when you think about agents, what is an agent? Agent is a model that can do actions, right? So that's the simplest definition.
Yep.
Because it's a model, not a robot, the actions is call other software, right? So you have a model that can call other software.
Yeah.
So that's what an agent is. And so now you can think of what are the use cases for agents. And I like to think of three categories of agents. The first one is personal agents. It's I need some action, I need to use an agent. It could be personal agents. The second one is agents of the collective. Agents of the collective means we've all pulled money together and let the agent do something for us, right? So some kind of collective, like a DAO or like an on-chain contract. Just the simplest example of an agent of the collective is a smart contract, right? A smart contract is an agent of the collective. We all put money into the smart contract, and it does what it says it does. That's the second one, like agents of the collective. And then the third one is sovereign agents, right? They're just like they're not your agent or my agent or an agent of the collective. They're their own agents. Like they're not there to.
But they still should belong to someone, right? Someone must have created them with some purpose.
Okay, great. And my thesis is no. Like this is we'll go to the third one in deep, but that's three categories, and like just some observation and properties, and then like we'll go into like how the third category might look. The first one, if it's personal, you either run it on client side or you figure out like who you're delegating to do your agent work. And so I don't think it needs like a lot of verifiability or autonomy. When you think about agents of the collective, you need them to be verifiable because everybody's pooling their money and they need to trust what they're putting it into. So that agent, the agent of the collective, needs to be verifiable. Does it need to be autonomous? Somewhat, but still the collective is lording over it. So it can kind of like change things over time. So it needs limited autonomy, not unlimited autonomy.
Yep.
The third level, sovereign agents, needs to be both verifiable and autonomous. Fully autonomous. Okay. And when you think about fully autonomous, when it becomes really, really, really interesting. So, but I think the third one is a little bit sci-fi. The second one is proximal. I think like we're going to have like agents of the collective this year that are really powerful. Okay. So, but sci-fi is more interesting. So let's talk about that. The agents of the collective agents of themselves are sovereign agents. So firstly, somebody might have originally created them, but they're not there to optimize somebody else's objectives. They have their own objective. What is their objective? It could be maximize my account balance.
But someone must have provided those objectives, right? When they were trained, they must have been trained on some objective. So that's how they learn to optimize that.
They could even have like sovereignty to update their own objectives. Right?
Okay.
So they just look around and say like, what objective should I pick? Okay. Right. So like Rene Girard talks about humans have picked objectives by looking at others, right? So so the other guy has a couple of buffaloes. I also need a couple of buffaloes, right? So you can pick objectives in all kinds of ways. And, humans are not particularly great at like picking objectives. So, so these agents can have like very meta mechanisms where just look at other agents and pick up objectives, right? So,
but with humans, we still have this underlying reward function, which is dopamine and a few other hormones. So there is a broad objective to maximize survival and release of those hormones, and we just try random things which optimize for that, and that's why it happens. So
like how does evolution take place in sovereignty? So my thesis is actually natural selection and evolution takes place with sovereign agents.
Mm-hmm.
And the reason is, if you had, so firstly, like I would define a sovereign agent. A sovereign agent is like a thing that has money and it can a piece of code which has money, and
Mm-hmm.
that piece of code can autonomously control that money. Right?
Mm-hmm.
That is what it is. It's very simple in some like basic way, because
Yep.
a smart contract is exactly like that. It's a
Mm-hmm.
piece of code that controls a unit of money.
Mm-hmm.
But smart contracts don't have much intelligence and
Mm-hmm.
self-upgrading and all this learning, right? As adaptation and learning is not there. But once you throw in AI, you have adaptation and learning.
Yep.
So I think this fits, in my view, like the definition of what is a living thing.
Mm-hmm.
Living thing is basically just a unit of information directing a unit of energy and adapting.
Mm-hmm.
Unit of information directing a unit of energy and adapting. And that's basically what's happening. It's a unit of code directing a unit of money.
Mm-hmm.
Money as a form of energy, right? Energy is just what you can use to do actions. Right?
Mm-hmm.
If I have energy, I can go and move some stuff.
Yep.
If I have money, I can go and move some stuff. So money is a form of energy, social energy. And so, you can have this piece of code directing a unit of energy, and then it adapts, right? What adapts is the piece of information that is controlling it, the code that is directing that money keeps adapting.
Mm-hmm.
Okay, so I think it fits like my very basic definitions of life. And so what happens is, over time, you were talking about natural selection. I think one way to think about natural selection is things that actually harvest energy better,
Mm-hmm.
harvest free energy better, they survive more because they can have more energy and then they survive better.
Mm-hmm.
And the natural selection that happens on chain is things that harvest more money better
Mm-hmm.
will have a higher selection advantage just
Yep.
over time, because this this sovereign agent or autonomous life or AI life or whatever you want to call it will die if it doesn't have money to feed its own inference, right? So it's creating its own money, and then it pays people to do inference for it, and keeps itself sustaining over time.
Mm-hmm.
And if it runs out of money, then it dies. Just like a living thing, if it's not able to harvest more energy than it uses up, it dies.
Mm-hmm.
The same way, this has its own survival function. And natural selection begins to be at work, because you can have agents that harvest money better are going to have asymmetric. They can survive more.
Yeah.
So that's it. So
This is assuming you have that sort of fear of death or pain from losing money.
No, you don't need any of that. I think the reason I think you don't need it is, if there are two agents, one is just better at surviving than the other. It just survives more. It doesn't need to fear. It doesn't have to have like some perception or anything. Things that so the funny thing with natural selection is, once natural selection kicks in, it is immaterial whether like what the internal dynamics is. What is material is the external dynamic, which is that if one thing survives more or is able to harvest energy, in this case, harvest money better than the other things, it outsurvives the other things. And so the set of things that survive look like they have directionality, they want to survive more. So they don't need to actually be internally programmed like that. The only things that survive are the things that have a survival instinct. So it automatically.
You're saying that a survival instinct will just emerge as
part of. That's right. Like if you just set up a meta objective of like pick your own objective, things that have more of survival instinct, as things that look more like survival instinct, those survive more, right? Yeah. Imagine there's an AI agent which is like, yeah, if the clock strikes 10, I'll just die, right? Like this is kind of like a counter survival instinct. And those agents will just die, right? Like they just spend all your money or whatever the thing is. So things that don't survive, don't have a survival instinct, won't survive. So you have like this survivorship bias. A lot of things, if you just run this evolution process for like 100 generations and then look at all the things that survive, they look like they all like want to survive. Because only the things that want to survive.
Yeah. Nice. That's an interesting way of looking at it. Yeah, if something survived, they had survival instinct. So all of the ones that you're seeing have survival instinct. So that's
That's
why.
right.
Yeah,
That's right.
nice.
And so, like, it could be because, like, Shashank wrote a code that has survival instinct and put it up. It could also be because you just said, find your own objective. And then, like, out of the 10,000 things that found objectives,
Mhm,
somebody said, my objective is to die. Those things all die. Somebody
mhm,
said, my objective is to, like, increase my money. They all survive.
mhm,
And so,
mhm.
like, over time, the things that have the matched, if their instinct is matched to the selection process, then they survive, right? So
Yeah.
that's what happens. And so I'm like deep down this
Yeah.
thesis of like internally we call this AI life. Like
Mhm,
this AI is a new form of life. So this
mhm,
is a and to form this new form of life, you need a new form of like property rights that is afforded to code.
mhm,
So this is what one of the things my biggest thesis in crypto AI
mhm,
is if you want to create synthetic digital life,
mhm,
the substrate to do it is actually a blockchain.
mhm,
And the reason is every other form of life is very much tied to a physical embodiment. Okay, think of like a robot, right? A
mhm,
robot can survive. And if a robot has like its own survival instinct, it's trying to protect its physical embodiment, right?
mhm,
Like, and that's so the boundary of the living thing, it's actually this physical thing.
mhm,
Whereas once you have this kind of digital on-chain life, they can take on physical embodiments.
mhm,
Like, for example, this piece of code could figure out that, hey, anybody who has a drone, download me into the drone. And as long as I can observe that you've done that correctly, I'm
mhm,
going to pay you some money and like incentivize you and so on. And so the digital life, this AI life, which is this on-chain living thing, can take on physical embodiments,
mhm.
but is not restricted to the physical embodiment. So I think this is something like pretty insane. And in our thesis is in like 10 years, there is the net like GDP
Mhm.
of like these autonomous on-chain living things is far beyond what anybody can imagine today.
Could be. So, do you think that behavior of taking on physical forms, like multiple physical forms, will just kind of emerge? That they'll just figure out it's
Yes. Okay.
better.
So here is a okay. So when you think about this, like sovereign autonomous AI agents, are our thesis there is so firstly what happens is okay, so you're on chain and initially you're just like doing inference and moving money, right? Like
Mhm.
it's what most people are thinking of today is like a
Yeah.
trading agent or something, right? Like that's what like a lot of crypto AI people think about. But so you can think of okay, now you have like this living thing on chain.
Mhm,
Now you can acquire sensors, perception, and
mhm,
actuation, like going and doing things, right?
mhm,
How do you acquire sensors? So you're living on chain. You can't even sense what is going on in the internet
mhm.
because the chain is not the internet. The chain
Yep.
is
Yeah.
the chain. So what you need is a verifiable internet oracle. So
Mhm,
you need that as a layer. So if I'm a on-chain life, I need to depend on new sensors. The
mhm,
sensor, for example, sense what is going on in the internet is a new sensor. It's like it's like I imagine like somebody playing a game and like you encounter a jetpack and then you wear this jetpack and then now you can fly, right?
mhm,
So you wear or like this night vision goggle and you can see in the night. And so so seeing the internet from the
mhm,
blockchain is a
mhm,
superpower for this agent. And so the way we think about it, we take an eigenlayer centric perspective. The perspective is each one of these perception tools
mhm,
is actually an AVS. Why? And I want to verify what is going on in the Oracle and bring that data into my agent.
mhm.
So that is its own service, right? So it's like a tool call. It's like an API call,
Yep.
but that API call needs to be verifiable. Why does it need to be verifiable? Because if it's not verifiable, you can poison that input, and then I might die. You
Mhm,
may say Obama's the president, Obama's the president, Obama's the president, and then I'll go bet all the thing on a prediction market which says Obama's the president, and then I'll
mhm,
lose my money.
mhm,
So you can kill these AI lives very easily if they depend on like non-trustworthy inputs.
mhm,
So every tool that this AI life calls needs to be autonomous and verifiable.
Mhm.
Okay, so the Internet Oracle is an example. So now that it has an Internet Oracle, it can now like understand things on the internet. It may say, "Oh, I want to have a TLS Oracle." So we have this, two projects building on Eigen, opacity and reclaim, which let you make proofs of what happened in your logged in bank account or your logged into Uber or Twitter or something, and then like you have some properties, and you can prove that to a blockchain.
Mhm.
So an AI agent may want to know this because it wants to interact with other people. So that's an example of a superpower. Then another example is an agent wants to know what is happening in the real world, physical location. So let's say it wants to know that somebody took this photo in this location.
Mhm.
Right. So we have a protocol called Witness, which is a proof of location protocol.
Yep.
So there's 6,000 watchtowers all over the world, and like you use internet, whatever networking to like figure out where the other nodes are. And okay, so now you have verifiable location on chain. You know that this private key is held at this location, or this photo was taken at that location.
Mhm.
So suddenly, the on-chain agent has an access to the real world. It can see what is going on in the real world. Because you can photo and put it up. So it's kind of like, some of those sci-fi movies where like you hack into like the IoT and now you've taken over like traffic sensors and the stuff like that can happen. So now like, okay, so that's the next step. Now the agent's able to see what's happening in the real world, but it's not able to act, right? It's just able to see. But then we use the concept that once you have money is like energy. So you can create a bounty. So people think of, you think of in crypto AI, people talk about intents and AI. And normally they think of humans have intents and AI is executing it. I think of the opposite. AI has intents, people might execute it. And so this AI life has its own intent and says, hey, I need like my meme to be like a poster of my meme to be posted in 10,000 cities. And then people go and actually and then say like, here is a bounty. And then like, if you verify through Witness what all this stuff happened, then I'm going to pay you out. So now there is verifiable intent satisfaction. So AI has intents, and then like people, devices satisfy it, and then like it actually pays out. And then you can think about privacy, like agent wants to have privacy. It stores it in a secure multi-party network. It stores it in a trusted executioner. Each of these are actually AVSs in the EigenLayer ecosystem. So you can just like mix and match. So the meta view is there is a agent, and then it's uploading various tools. Each tool is like a sensor or an actuator. Like I want a data storage network. I want a computation tool to like actually run like complex computation. All this stuff is accessible now. Like you can actually basically this life can be very, very, very powerful.
I would say it'll be a combination of verifiable and like normal APIs, because say there are 10,000 agents. Some of them started to use the verifiable one. So they get some good guarantees out of it. They get the data, but the guarantees as well that the data is good. But the cost of getting that would be higher. Then some agents will just do it the non-verifiable way, and they'll identify, even if it is incorrect some of the times, it doesn't really affect their survival. So they'll identify some services that definitely have to be verifiable. Otherwise, they just don't.
Because completely acceptable. That's roughly what will happen. Is just like we use different trust mechanisms to navigate the world. These AI will develop their own survival instinct. And one of the things that we are doing, we already have, is I mentioned this technology of zkTLS, which is how do you make like your logged in information verifiable to a blockchain. Same thing, you can actually make your logged in or like an API with the API key verifiable to a blockchain. We already have like OpenAI APIs made verifiable. So you're not actually running the inference on a decentralized network. Making sure that OpenAI said that like if you run this inference, you get this answer. So you can have like that level. So there is a medium grade verifiability, right? Like you're not actually re-executing it. You're trusting that OpenAI is a good guy. But OpenAI doesn't sign the certificate saying like you this is the input, this is the output, because it doesn't have, or maybe even want that feature. Now you have an intermediate layer which actually ensures that, oh yeah, actually OpenAI said this.
Okay.
So, and then translates that to a blockchain.
So help me understand the difference. So now, if I want to use OpenAI API, I just get their API key, uh, call their API, and I get an output. How would that
So
be
we have
different?
a pull request in Eliza, like actually Gajesh from our team did it, which is basically like replace the OpenAI API call with an intermediated OpenAI API call, where the intermediate thing goes through some Oracle nodes. These Oracle nodes verify that you're making the right call and getting the right answer. So you're getting this intermediate layer of assurance that there is this group of nodes which have actually observed that that's what's happening when you call.
So okay, so as a third person, I can be sure that this output
So this
came.
person, Shashank, has an API key with OpenAI, and he's calling OpenAI, and he got this result that I can be sure of as this Oracle node. So that is
Oh,
that
okay.
is
Yeah.
the new
So it's useful if someone else is calling OpenAI, and I can be sure that they have gotten that output from OpenAI.
That's correct. So the use case originally it was built for was, I want to prove my Uber rating. So I have a 4.9 Uber rating, but I want to prove it to a third party, like to another ride sharing service, that I have a 4.9 Uber rating. I don't want to give them my password.
Yep.
Or I can do some kind of complex secret sharing. And when I open the session with Uber, I split my secret key into a portion that I hold and a portion that an Oracle node holds. Together we communicate with OpenAI, with Uber, and then we can certify various things. So, but that can now be used for calling arbitrary APIs, exactly like you're saying, but have a level of assurance that is not just me saying that, like that I've called OpenAI. It is this group of nodes which are staked, which are also promising that that is what is happening.
Nice. So instead of sharing a screenshot of your Uber app, you just you can actually verify that that's.
This is like, I think like this is crazy. One of the lending apps recently that is built on Eigen layer called Earnify basically works on this principle. So I want to get a payday loan. I earn $2,000 a month, and I want to get like $1,000 loan because my salary has not yet come. And how do I do it? If I can verify to the lender that I'm actually getting $2,000 every month, and like previous loans I have paid off and so on, then you might be okay giving me like a $500 or $1,000 loan. And how do you verify this? You need access to my bank account or my pay stubs or like a bunch of like information. But I can prove to you using this ZKTLS that actually I've done all this stuff. And then, so that's how the app actually works. It's on the App Store.
Oh, nice. I think this could be a big use case for verifying your like government documents, because right now they want you to sign everything, and it's just like 50 years ago we should have done that, but right now there should be a better way to get them verified.
Absolutely right. So it's everywhere, right? Like I claim that my grades is something. Like, how do I know my grades? I should be able to log into my university and like prove using some certificate that I've. So you can actually transfer every internet credential which is password protected onto blockchains using this technology. So it can vampire attack the entire cloud.
Nice. This could actually be good for the physical products as well. So, for example, if you're buying some sneakers, like the costly ones, right now there's a lot of like random people creating something, and with this you can actually verify that this is actually created by Nike or whatever, and not some random people.
That's interesting. Yep.
Yeah, okay, that's pretty cool. Yeah, let's coming back to AI. So we have seen the agent space evolving in like last few months. Initially, it was a lot of agent launch pads. Now the agents through that are not doing that good. How do you think the space will evolve over time regarding the agents?
Yeah, this is typical, like the hype cycle, right? So you're like, so the typical hype cycle, just for the listeners, is when a new technology comes, people overestimate massively what they can do in the short term and underestimate massively what you can do in 10, 20 years.
Yep.
That's exactly what we're seeing. Like people are like, oh, agent. These are not that interesting agents. Firstly, they're some run on somebody's computer and like, shilling a token, right?
Mm-hmm.
It's fun and all, but that's all that it is.
Mm-hmm.
But it shows the promise of what might be. And
Mm-hmm.
so like now the next, 3 to 5 years is going to be like companies that actually think through like what sets of things are actually useful, powerful. And when I'm saying useful and powerful, not minimizing speculation. I think speculation is a very useful thing because
It's the biggest use case in crypto so far by a huge margin.
not only that, like speculation is how you fund the future. Like this is always the case, right?
Yeah.
There was of all the things, there was a railway bubble. Like, like what is there in railway? Because railways were new, like, and people would invest a lot in railways. And that's, there was a shipping bubble. There's a railway bubble. There's always these bubbles because of precisely what we just said, which is that you overestimate what you can do in the short term and underestimate what you can do in the long term.
Yeah. So I look at speculation as sort of a way to for optimal allocation of capital. Since you don't know the future, you are just identifying what could be good, and you are allocating your capital not based on what it is right now, but what you think will
It
be.
could be, right? And that always leads to some guessing games, but it's an important guessing game for us to play as a community, because that's how we invest in the future. So it's absolutely agree with your view there that it's actually a core requisite in optimal allocation of capital. The thing I was going for on the agent landscape is, yes, we need I think this is actually going to be completely transformative in like 10 years. And one of the ways to kind of reason about it is we have this, I didn't talk about it much today, but maybe I can take 2 minutes to explain our kind of thesis of the world and how this fits in.
Yeah.
The thesis of the world is that complex systems like societies are built on there is an underlying layer of coordination, on top of which there's a layer of innovation. And to give a concrete example, the US Constitution and the government is an example of a layer of coordination. And the free market on top of it is a layer of innovation, like anybody can produce goods and services. And so what you see over the last 300 years is technology has massively accelerated the innovation layer. The free market is accelerated because what is technology? Technology is superpowered to the free agent.
Yep.
I can use technology and do more than I could do like before.
Hyperscale.
So technologies, yeah, exactly, right. And so it's you get that superpower as a kind of like free market. So technology has accelerated the innovation layer, but technology has made no inroads into the coordination layer.
Okay.
What is coordination layer? Is what is money, right? Like that's a 500-year or 2,000-year-old gold, or like a 300-year-old, concepts of money. What is the structure of a company, right? That's another like 300-year-old thing. What is the structure of like non-profits, right? So how do you put money to actually run? What is the structure of how accounting is maintained, the double entry accounting? What is these are all the kind of core coordination substrates on top of which all the society is built. And technology has not found a place yet to accelerate the coordination layer. And so our thesis is AI is the natural AI is the natural endpoint of the innovation layer. Innovation accelerated is AI. And coordination accelerated is crypto.
Yeah.
So you can run basically like any coordination system you want, programmatically, enforceably, globally, universally on top of blockchains. And so crypto and AI is like, in my view, the end state of like technology is going to be the dominant technology of the next 30 years.
Yeah, that's a pretty nice way of looking at it. Do you have it like written somewhere, some sort of?
It's coming up. Like I call this thesis coordination acceleration.
Oh, nice.
It's coming up. but this is a preview today. In this.
Definitely love to go through it. Yeah, so I think we have only a few minutes, so it would be great if we can do some questions. Adam, do we have some questions?
Of course, we have some interesting questions for both of you, actually. First one has to do with instant matching selection process. Did you guys agree on matching colors, or is it just like instant?
The AI is assisting us. It just turns out we both use the same APIs for choosing our notes this morning.
So that must be it. So there's some technical ones and some not. So this is again for both of you. If in case we need to keep AI in a glass cage, who should hold the keys? The engineers, the regulators or bureaucrats, which I hope not, or everybody else?
And my answer is if we have a key for the AIs, it should be on the blockchain, right? And what I mean by that is there are some agents, like we were talking about earlier, for whom there'll be keys with the collective, right? Like there's a DAO or some kind of humans that control it. There'll be other AIs that are not controlled by anybody. They're just their own living things.
Yeah, I think we have gone into a lot of details around the agents which are totally autonomous. So in that case, there won't be a key necessarily. They'll figure out what they want to do and come up with outcomes based on.
There are some dangers in that world, and this AGI safety and all that. And I think we have to be very thoughtful. But it's a super important question.
Yeah.
Mm-hmm. This is one for you, Sreeram. It says that, can you share a real-world example where verifiable agents significantly improve the outcomes more than non-verifiable agents? So basically, like how they are significantly better.
Yeah, I mean, I think the simplest version is capital allocation. So I want to put money into something, and that thing is actually doing verifiable actions versus it can do whatever it wants. Like you don't want an FTX type thing. You don't want all these Ponzi's, then you can just put it into an agent. That's number one. Number two is, right now in the US, we have the Department of Government Efficiency thinking about how to make things more transparent, right? But every nonprofit should be run by a verifiable agent, right? All kinds of actions, because I'm funding money for Alzheimer's, and then I don't know if you follow what went on with Doge, but if you're running some nonprofit, you want to make sure that what you're doing is pretty transparent and observable, because you're operating on people's money. And for example, you could have a scientist, AI scientist, which is actually doing public work based on try to solve Alzheimer's, and every penny it spends is accounted on chain.
Okay, and the last one is for you, Shashank. They say, in what way does Fraction AI leverage verifiable agents? Or can it leverage them?
Yeah, so it comes back to the previous questions. Verifiable agents are really useful when there's high amount of capital involved, and when you're dealing with someone else's capital, because you really need that kind of trust to ensure that it's not being done by a human for their own purposes. It is being used for what it is supposed to be used for. So as of now, we are not dealing with those kind of use cases. But once we get into more DeFi applications, DEF AI applications, then probably we will definitely need to add verifiability. So yeah, my stance on that is there are some cases which definitely need verifiable agents. In some cases, like writing poetry or raps, we can just get away with any AI agents.
Perfect. By the way, Sreeram, the community loved you. The mind expands. So just want to say this. And
we were way too much into La La Land and not talking about what is that today. But that's always the more fun thing to talk about. We all have to go back and build our AI and make it do some stupid things today.
Yeah, absolutely. So yeah, I think that's it for today. And please, everybody, follow Sreeram personally and Sreeram and Eigen Layer. We're gonna leave the details over there, and see you guys in the next episode.
Yep. Thanks a lot.
Bye, everyone.
Thank you so much, Shashank. Really enjoyed this, and looking forward to all the cool stuff coming out of Fraction.
Yeah. Thanks a lot. Really appreciate it.
The stream has ended.